soon. And let me get, we'll start from current slide. And I'm sort of sorry I made the announcement early. I should have made it while we had this up. Coming up in less than 2 weeks is Cougar Connection Week. All sorts of flyers posted all over the walls and doors. Pay attention to those, see if there's anything that you would like to tie into. Good activities. And there'll probably be some people coming around the classes talking about them as well. Okay, now let's just, okay. This was the, can you get your name, please? Second. Johnson, got it. My hearing is so bad. Okay, good. Okay. This was the last slide we did a week ago. It's been a long time since I've seen you. Okay. Just as a reminder, these are the rules for exponents. And they say when n, m, n, and p are integers, which is certainly true. We've only dealt with positive integers, well, dealt a little bit with negative integers, but these are true for whatever integers. And believe it or not, these are true for all real numbers as well. But right now we're going to stay with the integers. Okay? So here's examples of that. How would I simplify a to the negative 7b cubed? That looks pretty simple to me. Can I get your name, please? Lexi. Okay. That looks fairly simple and straightforward to me. The only thing that is a little bit of a complication here, because a lot of times they don't like you writing this, what is the only little bugaboo there? The negative on the exponent. How do you clear that and make it positive? Second? Oh, you put a line through it, yeah, and make it positive. Yeah, that would work, wouldn't it? No. Okay. So what would we do? I got to get my pen activated. Here we go. How would you write that? Without a negative exponent? Okay, make that 1 over a to the 7th times b cubed, which would then, a little bit easier writing, make it b cubed over a to the 7th. Either one of those is fine. This is just a little more compact and concise. Does that make sense? Anytime you see a negative exponent, if it's above the line, move it below the line. If it's below the line, move it above the line. And then you drop the negative sign. Okay? The next one, b. Here's x to the 4th, y 6, divided by x, y squared. What would you do with that one? A little louder? Okay, move the x to the minus 4th to the bottom. What does that become then? A little louder? Okay, y to the 6th over x to the 4th, y to the 2nd. You left off one little thing. That x that was already down there, okay? So let's clean that up a little bit. How can we do that? Any suggestions? Second? Okay, so you got y to the 6th over, and how do those combine? X to the what? I heard something, but I couldn't make it out. What would it be? Help me, somebody, I'm drowning. Okay. Okay, to the 4th. So multiplying an x times x to the 4th keeps the x to the 4th. New rules, okay? What's wrong with that picture? What's the understood exponent if you don't see one? Y. So what does that become? X to the 5th. Okay, maybe that's what you said. I can't hear well. And you still got a y second down here. Are we through? Oh yeah, we can simplify the y's a little bit. What would that become? y to the fourth over x to the fifth. There we have it. Now you can take as many steps as you need, but make sure you can't do anything to simplify any further. That can't be simplified any further. We got it. You could have done several steps at once and whatever, but take as many as you need so you understand every step you're doing. Does that make sense? All right. How about C, which is yes in Spanish? What would that be? Okay, 1 over what? D to the fourth? Is that what you said? I hope you did. Okay. And what have we lost? The 6. Where does it go? It stays in the numerator. So we either say times 6 or just 6 over d to the fourth. It stays upstairs. It wasn't part of the negative 4. So it stays upstairs. The d goes downstairs. Now, why in the world they say d cannot equal 0 here? I understand it can't. But they didn't say 8 is not equal 0 here. They didn't say x and y are not equal 0 here. Of course, they understood anything in the denominator cannot be 0, but they specifically said that. I don't know why. But it's true. Absolutely true. All right. Everybody agree with that? Any questions? How this happened on any of those? Well, I'm going to erase my scratch so that you can read what they do. And let's see how they do it. Okay, on the first one, all they did was move the a to the minus 7 downstairs, making a to the 7. They give them b cubed over a7. They did it in one step. We took 2. It doesn't matter. Take as many steps as you need. Okay? On the second one, several ways you can go about this. Here's how they did it. I'm not saying I like this way any better. In fact, I don't. But it certainly works. You got x to the minus 4 here, and you got an x to the 1 down here, but that's in the denominator, so you subtract that exponent. So x to the minus 4 minus 1, because it's in the denominator. Y to the 6 minus 2, because that one's in the denominator. Anytime you're dividing bases with same base, different exponent, or same exponent, you keep the base and subtract the exponent. That's what they did here and there. Okay? So that, step 1, and that you're not through, that becomes x to the minus 5th, y to the 4th, 6 minus 2 is 4. And, still not through, one more step, move that x downstairs to lose the negative sign. So y to the 4th over x to the 5th. Same answer we got. They went about it slightly different method. Still works. As long as all the steps you do are correct, you should come out with the right answer. So take correct steps. Okay, that's the bottom line here. Any questions? All right, good deal. Now, that was, I don't even give example numbers. The example on the bottom of page 14 in Module 10. Okay, they renumber all the pages here. And they have the solution given to, and you see, oh wait, we haven't done C yet. Sorry, let's do C. Okay, C is, now this time they pulled the 6 on the outside, because that was 6, times 1 over d to the 4th. Okay, and once they got 1 over d to the 4th, then they can write that as 6 over d to the 4th. So that's one way to do it. We did it slightly differently, but it still worked. Okay, still came up with the same answer. Any questions on that? All right, good deal. So that was the example, bottom of Module 10, page 14, with the solutions, top of page 15. Now, there's a check your understanding, okay? 3 examples given here. Please do those, okay? Ignore the fact that the answers are right below them, but, please do those. In your book, is the answer right below them? I know in my book it is, but I thought maybe it's only because it's teacher edition. All right, that's on page 15 of Module 10, okay? And let's go to the next example on that page. They don't do. Shame on them, okay? So, do you need the check your understandings to be done, or you want to move on to the next one? Check your understandings are just like the 3 we just did. Do you need more of them? Huh? Move on, okay. All right. I think there's a website called that, moveon.org. Okay. Here's another one. Simplify this. Minus 35, a to the 6th, b to the minus 2, divided by 25. I'm sorry? I can't hear you. Is that what?
Yes.
I can't hear it, sorry. What was the question?
You said is that 8 to the 6?
8 to the 6, yes. Sorry about that. My hearing is so terrible. Okay. Denominator is 25a to the negative 2nd, b to the 5th. Okay? Now, how would we proceed here? Any first thoughts, observations, whatever? I'm sorry? Simplify, how would you do that? Okay, there's common factors between that. Now, here's something else I do. You don't have to. It's not any better or worse. But I like to deal with the minus signs first. Here we have a negative in the numerator and a positive in the denominator. I'm not talking about exponents. I'm talking about the whole expression. Well, negative divided by positive is going to be negative. So I think I like to pull the negative out front. The whole expression, the answer is going to be negative. Now I'm not going to worry about the signs anymore. I've got it out front. Now, what did you notice about 25 and 35 or 35 and 25? Common, what? Common factor of 5. And if you factor a 5 out of 35, what do you get? 7. And the denominator would be a 5. Okay? You're taking care of the numbers. You can't simplify those anymore. Okay? Let's deal with the variables. What can you do with the variables? Help me, help me. A little louder? Okay, how do you mean?
6 minus negative 2.
All right, and what would that be?
8.
8. So that would be a to the 8th. Perfect. Because let's deal with the variables that are similar. Okay, a is the numerator and denominator, and the rule is we have same bases, different exponents, divided, subtract the exponents, and that gives you a to the 8th. Next. Okay, so you're going to do a b, and if I understood you correctly, negative 2 minus 5, is that what you're saying? Okay, good. I'm glad you said that. Okay. Okay, so that would be negative 7/5 a to the 6, b to the minus 7. Okay? Anything else you want to do with that? Yes, move b to the bottom because that's a negative exponent, so that would be a negative 7/5. And the a to the 6 stays upstairs, and what happens downstairs? Say again?
It's 7a to the 8, right?
I'm sorry?
7a to the 8.
I can't read my writing. Okay, sorry, you're right. Okay. How that became a 6, I have no clue. That's a to the 8th. And what about the b? B to the 7th. Perfect. Done. Excellent. Everybody see that? Okay, check and see what they did in the book. Negative 7a to the 8th over b, 5b to the 7th. Perfect. All right. Speaking of perfect, who came in?
Yeah, you do.
Good. So what's your name, please?
Side.
Say again?
Side. Side board.
Okay, Saya. Got it. I don't hear well. Sorry about that. Okay, got it. Anyone else come in that I may have missed? You didn't hear me call your name. Okay, good deal. All right, that's the A part. Let's do the B part. The B part is a negative 2x times a 3 x to the minus 2, but that parentheses is raised to the minus 3 power. Okay. Where would you begin on a problem like this? Second?
Distribute the negative 3.
Okay. This negative 3? Okay, yeah. I think that's a good thing to do. Okay, I see what you mean by distribute. Okay? I wouldn't have thought in those terms, but it's sort of like that. So the negative 2x is by itself here. Let's not mess with it yet. Let's deal with that exponent. Good place to start, the negative 3. So that's a negative 2x. Okay? Now, how do we deal with that negative 3 there? And actually, your term is pretty good, though we don't usually think of it in this context, but it is pretty good. Okay? So, believe it or not, you start with 3 to the negative 3, and you can finish it for me. A little louder. X to the 6. Perfect. Now, what does that become? Okay, I like to pull that minus sign out. There's only one minus sign in there. Minus times plus is going to be minus. Let's get that on the outside. And what else do we have? 2. Say again? X to the 6. I like that. Over 3 to the 3rd. You're right. You move it downstairs, lose the minus sign on the exponent. Okay? Just a little bit of cleanup we can do here. What would that be? Minus out front. What's your coefficient? 2x to the 7th over, oh, there's Gary. No, not 9, wait just a second. 27. X squared, 3 squared is 9, 3 cubed is 27. There we have it. That should be our answer. Minus 2x to the 7th over 27. Can be written as negative 2/27 times x. 7, I can't read my writing. But either way is fine. And that is exactly what they have in the book. Negative 2x7, x to the 7th over 27. Perfect. All right. There's some check your understandings here. 2 more of those, very similar to what we just did. Do you feel like you need more practice with those, or you want to do those on your own? You let me know. All right, here we have, help me with the name. Ariana. Okay, there you are. All right, I see the 2 dots there too, Ariana. Good deal. Anyone else come in since when I wasn't paying attention, I didn't get your mark. All right, what you want? Do a couple more of those or move on? Move on. Okay. Well, the move on here is simply your homework. Okay. Please do these. Check your understandings. There were 3 of them so far. One was after the examples on page 14. And this is Pablo?
14.
Huh? Martinez. This is get wrong. Right? Okay. All right, good deal. We're filling up. We're only missing Seth. He hasn't come in yet, right? Pablo and Jayla. Is that right? Ooh, good attendance, folks. All right. So after you do the check your understandings, 1, 2, and 3, they're on pages 14 and 15. 14's check your understanding 1, 2, and 3 are on page 15. And then you have the objective 10.4a practice problems, and those are bottom of page 15, top of page 16. 3 at the bottom, 3 at the top of the next page. Please do those. Now on those, do they give you the answers on the side? Okay, that's only the instructor edition. Got it. Okay. So on the check your understandings, do they give you the answers beneath those? Just above that objective. Practice. No, okay. All right. So that's just have the answers given. Because, I need more help. Okay, got it. All right, now, all right. That finishes objective 10.4a. Any questions on that before we move to 10.4b? Okay, all right. So let's discard this. I just love that they have all these little bitty files here. Okay, 10.4b. And it'll open up one of these years. Maybe. Perhaps. Here it comes. Any questions on anything so far? Okay, let's just take this moment to look. We are making good progress. So there's a real good shot we're going to finish Module 10 today. That being the case, I really need those quizzes in either today or Monday, okay? If you can get them to me tomorrow or Friday, that's fine too. Remember, Friday I'm on the Birmingham West Campus, but I'll be glad to take them. And that means that the odds are, if we do finish this today, the test can be as early as Monday. Are y'all okay with that? Okay? So let's, finally it opened. Okay. So let's do, Module 10 is still polynomials. I'm glad we have another slide telling us that. And 10.4 is still integer exponents and scientific notation. We did integer exponents. Now it's time for scientific notation. So there we've wasted 3 slides with absolutely no math on them. Okay, but we'll use scientific notation. Here is the background. Very large and very small numbers are encountered in science and engineering and lots of fields pretty frequently. For example, the charge of an electron is 0.000000160 coulombs. Okay, that's a pretty small number. Okay, that's the charge on a single electron. Okay, who wants to write all that many zeros and then you have to count that many zeros to see if you got it right? Not a good way to go. Way too many opportunities for error in that, right? You might miss a zero or put an extra one in or count them wrong or something else. Not good. These numbers can be written much more easily in what they call scientific notation. In scientific notation, a number is expressed as a product of 2 factors. The first factor is a number between 1 and 10. The second is an exponent power of 10. Okay? So here's what we do. Okay? You see the decimal here. To get this to be a number between 1 and 10, we have to move this decimal after the 1. Now it's 1.60, and that's between 1 and 10. So how many places do we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that determines your power of 10. You moved it to the right, meaning it was a small number, so its exponent is going to be negative. So that'll be 10 to the minus, what did I say, 19, I believe it was. And let's see, this must be Seth. All right, good deal. All right. So now we're just missing Pablo and Jayla. Almost perfect attendance. Way to go, folks. Okay, so that's what we're going to do. So change a number written in decimal notation like we have here to scientific notation. Write it in the form of a times 10 to the n, where a is some number between 1 and 10, and n is some integer. So the a on this one would be 1.60. Now, you might want to ask, why do you put that 0 at the end? Well, it must be significant or they wouldn't have put it there. These zeros up here, not significant. They're just filling places until you get your first significant digit, which is your 1. But the one at the end is significant. So don't lose that. It's 1.60, and then the n here is how many places you move that decimal point to get to that. Since this is a number less than 1, that's the n is going to be a negative number. Okay? If you had moved the decimal this way, which we'll see in a later example, then it would have been a positive. Okay? So a is 1.60. Your n here is negative 19. That's an integer. Remember, integers can be positive or negative. Make sense? All right. For numbers greater than 10, you remember your first digit is going to be, the a is going to be between 1 and 10. If you got anything greater than 10, you're going to move your decimal point to the right of the first digit, which is moving it to the left. So if this is 240,000, you find the decimal point here at the end, move it 1, 2, 3, 4, 5 places to get it between 1 and 10, 2.4. And then these zeros are not significant, so don't write them down. 2.4 times 10 to the 5th. Okay? 93 million. Does anyone know what's significant about 93 million? It's approximately how many miles it is between Earth and Sun. Okay? 93 million miles. If you want to write all that many zeros down, well, much easier to write. Move the decimal from here. That's 3, 6, 7 places, 9.3. None of those zeros are significant. Times 10 to the 7. Much more concise, easier to read, and easier to deal with. Okay? Did someone come in or leave? Oh, you okay, good. All right, I already got the present. Okay. Okay. For numbers less than 1, remember you have to have that first number, the a, between 1 and 10. If it's greater than 10, you move it to the left. Less than 1, you move the decimal to the right. Move the decimal to the right, to the right of the first non-zero digit. Okay? See, all these are zeros here. They're just placeholders. That's all they are. Actually, the 0 in front is just to say, hey, there's the decimal. Okay? And those are just placeholders. So move it 1, 2, 3, 4 places. You get 3. That 0 is significant, so you put the 0.0, 3.0 times 10 to the minus 4. See that? All right. You tell me what that would be. 8.32 to the negative 5. Negative 5. Got it. Perfect. Make sense? All right. Good deal. All right. Let's see. The exponent n is negative because this number was less than 1. So the exponent's going to be negative. It was a decimal number, way out there, so it's going to be a negative. The absolute value of the exponent is equal to the number of places the decimal point has been moved. So that's why you count. Okay? And here we have Pablo, right? Okay. Down to 1. Missing Jayla. And that's the only one we're missing. Great attendance, folks. Keep it up. Okay. Any questions on this slide before we move to some examples? So let's do this. Write the number in scientific notation. You tell me how to do that first one. Okay, 8. Whoa, let me get my pen back. Where are you, pen? There you are. Okay. All right. 8.243. Okay, put down all the significant digits. Those zeros at the end are not. Occasionally they might be. And if they were, they're usually put a bar over the one that's significant. And if it is, then you put all those down there through the significant ones. Most of the time, you're not going to mess with those, okay? But occasionally, I've got a physics book I'm teaching from now that puts those bars all over the place on those zeros. Okay, you got the first part. What's next? Times 10 to the, okay, that's 3, 6, 9, 2 more, 11th power. Perfect. Does everybody see that? All right, good deal. How about B? 9.61, that's the easy part, times 10 to the negative, let's see, 1, 2, 3, 4, 5, 6, 7. You're absolutely right. 9.61 times 10 to the negative 7. Does everybody see that? Any questions? Very good. All right. Now, there's 2 check your understandings. There are check your understanding 4, an A and a B there. Please do those. Here's my suggestion to you, especially if this is a little fuzzy, new to you, or it's been a while. As soon as you get out of class, if you don't have another class coming up right away, find someplace you can go and do at least these check your understandings. They're just like the ones we just did. Do them while they're fresh on your mind. That sort of makes them yours. Right now, you're a spectator. You're watching or listening to other people do it. Do it yourself. Okay, that's the best way to do it. Then, at that same time, you can do the practice problems if you want, or wait a while and do those later. It doesn't matter. But please do the check your understandings, especially if you're not quite sure on it. Go back and do that as soon as you can. All right. I'm sorry. That's on page 16 in Module 10. Okay. Let me clear my scratch so you can see how they do it. Okay? The solution, just like we got, 8.243, put down all the significant digits there, times 10, and when they're on this side and you have those groups of 3, really easy to count. 3, 6, 9, 2 more makes 11. Really easy that way. Okay? On the B part, though, you move the decimal to just to the right of the first significant digit, which is 9, 9.61. There's no 0 at the end, so nothing else to go there. And then you have to count. And these are a lot. To me, my eyes go weird when I do this. There's 3 zeros, 3 zeros, 6, 1 more is 7. 10 to the minus 7. Make sense? Good deal. Okay. What if they give you a number in scientific notation and they say they want you to write it with a decimal point? Boo hiss. What would you have there? 3.245 times 10 to the 9. That's going to be a big number or a small number? Big number, okay? And what would it be? Now, here's a key, 10 to the 9. That's nice and divisible by 3, right? So it's going to be a, what? 3, comma, 450, comma, 0, 0, 0, comma, 0, 0, 0. Very good, okay? How about that? Okay, the decimal's going to... Okay, now no comma there. 8 is not divisible by 3, right? 6 is, and you're going to have 2 left over, so it's going to be a 2, 3, 0. Those are the 2 that were left over. 2, 3, 0, then your comma, 0, 0, 0, 0, 0, 0. So you get 6, 3, 6, and 2 more is 8. You see how that works? Now, I don't always do it that way. Here's how I often do it. Okay, let's take that one. Let's move the decimal, and I'm sorry this is going to be messy, 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And put a 0 in every one of those places there. Okay, then go back and group them by 3s. That's one way to do it. That's how I usually do it. I don't usually think through it that hard. Just write the zeros in there. 3 is the first place, then 7 more zeros after it, and then you got it placed. It's messy, but it's doable. Okay? Now, when the exponent is a negative exponent, what kind of number is that going to be? Very small number. Your decimal number, and you're moving the decimals that way. So what would that be?
0.0081.
Excellent, excellent. Here's a little clue there. Since this is the first one, you got 2 more. So subtract 1 from this, just the absolute value of that. 2, that's how many zeros are in front. Okay? Because the first one place is going to be to get in front of the 8, then you got 2 more places to go. So 0.0081. Okay. Now, this 0 in front is not absolutely necessary, but it's usually a good idea to put it there, because if you are writing this in a sentence, okay, you were talking about something with that small a number in it, and you don't have that 0 in front, you don't know if that period is the period at the end of the words that came before, or if that's a decimal point. Okay, yeah, with this one it's pretty clear it's got to be a decimal point, but if that was just 0.81, that could be a period there, or it could be an 881 starts the next sentence. So it's usually good to put that 0 in front just to indicate that's a decimal point, not a period. Doesn't look the same. Okay, how about that? What would we do? Okay, that was 5 zeros, a 0 point, 5 zeros, then the 634. There you have it. 1, 2, 3, 4, 5 zeros before you get to that decimal. Perfect. Any questions on that? Now, those are my little rules that I use. You don't have to use them. Just move your decimal. And in fact, you can do it this way too. I'll do it on the 8. There's your decimal there. 1, 2, 3. Put zeros in here. And then put 1 in front just for fun. Okay? That's the other way to do it. And that's how I often do it, and it's really messy. But it's real easy to do. Okay? Any questions on that? Okay? The rules for multiplying and dividing with numbers of scientific notation are exactly the same as those for calculating with algebraic expressions. The power of 10 corresponds to the variable. I'm not sure I understand exactly what they mean there. And the number between 1 and 10 corresponds to the coefficient of the variable. Yeah, I kind of get what they're saying. It's a little bizarre, but I never would have thought of it in that way. But yeah, that's correct. Okay? So, what would that be? 4x to the minus 3 times 2x to the 5th. Whoa, it's been at least 15 minutes since we did that a long time ago. What would that be? Help me. I'm drowning up here. 8 x to the second. Perfect. Okay? Now, what they're relating this to, if that was 4 times 10 to the third, negative 3, times 2 times 10 to the 5th, that's what they're suggesting. When I read this, I said, what? Okay, so that's what they're suggesting. You do it the same type of way. You multiply the numerical parts, 4 times 2 is 8, and then you combine these just like you combine. You're multiplying 10 to the minus 3 times 10 to the 5th is 10 to the 2nd times 10 to the 2nd. Now, where you get into a little bit of a problem with it is here. What if this was a 5 times 2 or a 4 times 3? Let's do 4 times 3. then you would have had a 4 times 3 would be 12 times 10 to the second. But that's not in scientific notation, is it? Because 12 is not between 1 and 10. Okay? So then you would need to move the decimal one place and make it a 1.2. But if you moved it one place there, you made this a smaller number, so you make that a bigger exponent. 1.2 times 10 to the third. Okay? We'll probably do examples like this, but they didn't show it here. Okay? Here, what would that be? Okay. I'm having trouble reading that. So x to the fifth, okay? I heard 2x to the seventh? Yes. 2x to the seventh. That's what the answer is. Same thing here if you're dividing scientific notation. Divide the number part, 2, just like you did before, and then you do this division just like you would any other. 10 to the minus fifth divided by 10 to the fifth divided by 10 to the minus second. 5 minus a minus 2 is positive 7. 2 times 10 to the 7. Okay. And again, they showed you the easy one. What if this had been 3 divided by 6? Then you'd have a 0.5 times 10 to the 7. But 0.5 is between 1 and 10. So there you have to move your decimal one place this way, making a bigger number. So you drop this by 1. It'd be 5 times 10 to the 6th. If you make this a bigger number, drop that by 1. If you make this a smaller number, increase that by 1. Okay. Because you're moving just a decimal point. Again, that's my little rule. Let's see if the book comes up with something better. Probably. Whoa! They don't do it, do they? They just go to blankness. So let's do the focus on operations with numbers written in scientific notation. Okay. This is on page 17. It says multiply or divide. Here's the first one. 3.0 times 10 to the fifth times 1.1 times 10 to the negative 8. Okay. How would you do that? How would you do that? Help me, help me. A little louder? Okay, I can't hear. I hear something, but I can't make it out. Do what? Yeah, actually you will, because one's positive and one's negative, so you will. You add a positive and negative number, which is subtracting in a sense, okay? But let's deal with the number part first. Multiply the numbers, and that gives you 3.3. Excellent. Okay? Times 10. Now just determine what exponent it's going to be. A little louder. Negative 3. Excellent. There it is. There's your answer in scientific notation. Now, I know this isn't what they are dealing with now, but I will point it out to you. You might ask yourself, why did they put 3.0? Why didn't they just put 3? Well, they're indicating that measurement, whatever that is good to the nearest tenth. Not just good to the nearest unit, but good to the nearest tenth of a unit. So it's a 3.0. And when you multiply, and this is in scientific stuff now, scientific notation. When you're dealing with scientific stuff, when you're multiplying or dividing, you can't get more precision out of the problem than you put into it. This is 2 significant digits. That's 2 significant digits. So therefore, the answer can be 2 significant digits. If they had said just a 3 times 1.1, that still would be 3.3, but you can't, this is only 1 significant digit, 2 there. you would have to round that to 3. Okay? I know it seems bizarre, but that's what you would do. We're not, this isn't science, this is math. We're going to deal with it as we come to it. So don't worry about that part. But for those who are in either now or later science courses, you'll probably run into that. So just to give you a heads up. So that's the A part. Let's do the B part. 7.2 times 10 to the 13th divided by 2.4 times 10 to the negative third. All right, what in the world are we going to do with that? Okay, divide 7.2 by 2.4. You might need a calculator, or you might be able to do it in your head. What does that give you? 3. Again, 2 digits, 2 significant digits. I would write that as 3.0. Okay, just because you're trying to keep your significance. Okay, times 10. I can do that part. You tell me what exponent. To the 16th power. Perfect. When you're dividing exponentials, same base, different exponents, keep the base, subtract the exponents. 13 minus a minus 3 is 13 plus 3, which is 16. See that? Now let's see what they gave as answers. Oh, shame on them. They wrote it as just 3 times 10 to the 16th. That's perfectly okay in a math book, okay? In a science book, that would have been 3.0. But it's perfectly all right just to put 3. I'm sorry, I'm looking at the wrong. Where am I looking? Oh, yeah, and they put 3. Yeah, I'm sorry. I was looking at the other answer, and I thought that's not the right answer. Yeah, but it's 3 times 10 to the 16th. Or you can do 3.0. Doesn't matter. All right. Now, what they didn't show you is what if this would have come out. Okay, let's go here. What if this would have been a 3.1 here? Someone do that on your calculator. 3.1 times 1.1. Do that on a calculator. Say again? 3.1 times 1.1. 3.41 times 10 to the minus 3. In that one, the book would say that's okay. But in science, you would then round that to 3.4, drop the 1. You round it to the number of significant digits. And if this would have been, say, a 7.3 and a 2.4, what would that have given you? 7.3 divided by 2.4. Use a calculator. 7.3 divided by 2.4. It stops there?
3.04166667.
Okay. It goes on and on and on. There, especially, you just round it to 3 point, what do you say?
04.
Okay, 3.0. You would then do it 3.0. Just to the number of significant digits you have there. Okay? You don't have to worry with that. This is not a science course. It's a math course. But if you get science, you'll learn to round according to how many digits you have. Okay? Now, there's a check your understanding 6 there. Do you feel like you need to do more of those, or you're all right to move on? But then, after class, sometime as soon as you can, do your check your understandings. And also do, for homework, your practice problems, and you have 6 of those. Do all 6. Those solutions are given later, but do all 6 and see if you can get the right answer. Then go over a few pages and check your answer. Any questions? All right. All right. So let's move on from there. Were there questions? Okay. Say that again. Only if you're having trouble getting the answers that are in the book. Okay, they're exactly that. They're practice. Okay? If this was a piano course and I say, go home and practice this piece. Well, you may come in and play it for me, but then that's for the grade. That's what the test is going to be, okay? But the practice, if you can't get the answers they have there, bring them to me, and I'll try to help you figure out where you made your errors. That's what the practice is about, okay? So we're moving on to 10.5. 10.5. So 10.5a. Taking a while to open, but we'll get there, I guess. All right, here we come. Okay. We'll go from current slide. And we still have Module 10 polynomials. I'm glad they repeated that slide. And 10.5, division of polynomials, which we sort of already been doing as long as they were small monomials. Now we're going to do, we'll divide a polynomial by a monomial. That'll be 10.5a. Guess what? 10.5b is going to be dividing by a polynomial. So let's see how we divide by a monomial. Okay? Actually, I'm not going to do it this way. What if this was our situation? You have a over c plus b over c. How would you do that? Yeah, you have common denominators, so combine the numerators over the denominator, and that's what you get. Well, what is this? This is a division of a polynomial by a monomial. So how do you do it? You do it the other way. You put this term over this one plus this term over that. If that was 17 terms there, you put every one of them over the c, and then you simplify. So that's how we divide a polynomial by a monomial, divide each term in the numerator by that common denominator, and write the sum of the quotients. Okay? So that's all you do. Just it's exactly the reverse of finding least common denominators, adding numerator, keeping denominators. Here you have a denominator, split them up, and put each numerator over that denominator. Okay, each part of the numerator over it. So let's say it with real numbers. What would this be? Divide 12x squared y minus 6yxy plus 4x squared by 2xy. Let me get my pen back. Okay. What would the first term be? 12x squared y over 2xy. Next. Minus 6xy over 2xy plus 4x squared over 2xy. Perfect. For your first step, what do you do now? Simplify. What does the first one become? 6x. Success. 6x. Okay, never mind. Okay. Next. Minus 3. Next. Plus 2x over y. Y'all are good. Just split them up and then simplify. And that's a perfectly good way to leave your answer. Okay? Everybody see that? Everybody got it? Getting it? Good deal? All through? All right. Anyone still needing? Well, hang on because you're going to watch them do it too. Let's see if they do it any differently. I guess not. You start out with, I could have left that all up there, couldn't I? Okay? You start off by splitting it out. 12x squared y over 2xy minus 6xy over 2xy plus 4x squared over 2xy. And then simplify. 6x minus 3 plus 2x over y. Just like you did it. Perfect. Yes? This last one? Yeah, got it?
Yeah.
2 minus 1 is 1. Okay. Good question. Good question. Any other questions? See how it works? All right. Good deal. There's that is. Okay. There's a check your understanding 1, top of page 19, module 1019. Please do that. Does anyone feel like you need another exercise with it? I'll be glad to do that in class. Okay. Speak up, because I don't mind. Okay. Whoa! That was a short slide set, wasn't it? Okay. They do have another focus here. So let's focus. Folks, focus. Okay. Can anyone see any difference in this focus and the oh, yes, there is. Wait a minute.
No, it's not. It's the same.
Okay. Actually, what I messed up, they had a focus. They skipped, didn't they? Yeah, I'm sorry. Yeah, the first focus, they skipped. Let's do the first one. 6x cubed minus 3x squared. This is even easier. Plus 9x divided by 3x. How would you do that? This is easier. Yeah. Say again. 6x cubed over 3x minus 3x squared over 3x plus 9x over 3x. And what would that be? 2x, say again, squared minus x plus 3. Very good. Very much easier one. 2x squared minus x plus 3. That's the one they skipped. Then there's a check your understanding 1, top of page 19. Do that one. We did the second focus, and then check your understanding 2. That's one you can do. Okay? Then they give 4 practice problems. Please do those. Excellent things to do to prepare yourself for the test. Okay? And that's, say again? Okay. This sort of flies, doesn't it? Okay? So let's get through with this one and move on to 10.5b. Okay? I just love that they have all these little bitty PowerPoints. All right. Now, here's just a note. See, they have 6 of them in this one. Okay, that first one is the one we've seen on every one. This just introduces 5b. And this introduces 5 again, which we've seen before. This does 5b, and then they just have 3 slides here. So, wow, how efficient. Okay, we'll go from current slide and do that. Module 10, polynomials, nothing new there. Section 10.5, division of polynomial, nothing new there. But here is 5b, divide polynomials, as if we weren't already doing that. But what they mean now is what if you have multiple. To divide polynomials, you use a method similar to that used for division. Okay, let's back off. Okay, give me a number. Second? No, you said one. What'd you say? Give 911. Okay. Whoa, let me get my pen. Okay. 9. Whoa, where did it go? All right, there we go. 911. Give me another number. Bigger number. Second? 682,000. Okay. Perfect. Nothing wrong with that. How do we divide longhand? Don't tell me pull out your calculator. How do we do long division? Okay. Here's how. We take the first digit here into the first digit there. It won't go. So do the first 2 digits. 9 will go into 68 about how many times? Y'all okay made up the numbers, so don't gripe at me, okay? Now we're going to 68 about how many times? 7 times. Okay, so we'll put the 7 here. Now, why did I put it there? Because there's 3 digits there. It won't go into 3, so it goes there, okay? Then what do we do? What do we do next? We what? Not yet. Multiply. So you divide first, then multiply. 7 times 1 is 7. 7 times 1 is 7. And 7 times 9 is 63. Now what do you do? Subtract. And what does that give you? A 3 here. Oh boy. Those calculators have made you rusty. 4 there. And say again. 4 there. Got it. Then what do we do next? Bring down the next digit, 0. And then you do what? Divide again. 9 will go into 44 about how many times? Say again? Won't go quite 5. That'd be 9 times 5 is 45. That'd be too many. So 4 times. Okay? And then we multiply. 4, 36. Didn't know you'd be doing such high-level math today, did you? Then you do what? Subtract, and that gives you a 6. I believe it's an 8. Oh, rusty. Okay. And this one would be a 7. Very good, and that does. Okay. Now, time out. Okay? We should have done it here. I should have stopped here and said, could you go any more? No, because the remainder was less than the divisor. So that was good. Now your remainder is less than the divisor. You're good. If that had been greater, then you go another time. Make it 5 rather than 4. But we knew that wasn't going to work. So now we do what? Bring down that last 0. Okay. And then you do what? Divide. And what does that give you? 8. Okay. Then you multiply, and that gave you 8. 8. I'm glad you gave me 911. It's easy to multiply. It's 72. Okay. It's also an emergency. Okay. Then you do what? Subtract, and that gives you a 2. 7. Okay. And 5. And what do you do with that? That's your remainder. There's no more zeros to bring down or anything else. So what you can do is write that as plus 572 over 911. Write that as a fraction. Your remainder over your divisor. Okay? There's your answer. 748 and 572 9/11ths. Okay? Really nice number. Thank you so much for that nice number. Okay. But that's how you divide whole numbers. Guess what? That's how you divide polynomials. Sort of. We'll follow the same pattern. Okay? To divide polynomials, use a method similar used for division of whole numbers, long division. The same equation used to check division of whole numbers is used to check the polynomials. I didn't do that, but we could have. What we could do is multiply 748 times 911. Do that one on a calculator, please. And then add 572 to it, and you should get 682,000. You can try that if you want to. See if you get it. 748 times 911, and then add 572 to it. You get 682. Excellent. Okay. So we'll do the same thing here. The quotient times the divisor plus remainder should give you the dividend. Y'all remember what to call those numbers, right? Okay. Okay, over here. We'll do this one. This is the divisor that's dividing into. That's the dividend. That's the quotient. That's the remainder. Okay? So they're doing the real simple one here. We like the big ones. Okay? 5 will go into 17. 3 5 is 15 plus 2 is 17. Boy, it's so easy. Okay? Now, any questions? If the term is missing in the dividend, you have to insert a term with 0 as a coefficient. That helps keep like terms in the same column, and it says that's illustrated in this example. Here it is, folks. What's wrong with that picture? Say again? A little louder. This is a division problem. We don't like them. No, we love them, okay? What's wrong with it? It's not in standard form. Your dividend is not in standard form. So that's the first thing you do. Write it in descending order of your powers. So, your dividend is what? 2x cubed. What's the next thing wrong with this picture? Missing a square term. That's where you put plus 0x squared. That's just 0, right? But it's a placeholder. It keeps everything in line. Next, plus 6x plus 26. That's your dividend. That goes in the house. What goes out of the house? X plus 2. Now, I don't know if they're going to show us this or not. I don't think they are. Shame on them. I'll try to show it to you before we're over with, just because it's fun. Okay? So, how do we do this division? What did we do before? We took the 9 and divided it into the first few digits, right? So this one we take the first term and divide it into the first term. So you do x into 2x cubed. How many times will that go? X into 2x cubed. A little louder? 2x squared times. Perfect. Then what did we do next? Multiply, right? We divided, then we multiplied. Remember? 2x squared times x is 2x cubed. That we knew. But then you do 2x squared times 2. What does that give you? Plus 4x squared. See why you need the x squared term in there? Because you wound up with 1. Okay? And then what do we do next? Subtract. Okay? Now these are fairly easy to subtract. Okay? But some of them, you could have signed numbers there. So what I like to do is change signs and add. So I'll change that to a minus and change the next one to a minus. And then I'll add. That way I make fewer mistakes. What does this add to? 0. Good. We wanted it to. What does this add to? Negative 4x squared. Right? And then what do we do next? Bring down the next term. Plus 6x. And then what do we do next? Divide again. And you do first term in the first term. X will go into negative 4x squared how many times? Negative 4x times. Perfect. Then what do we do next? Multiply. Negative 4x times x is negative 4x squared. Perfect. And negative 4x times 2 is negative 8x. Now you could subtract, but I like to change signs and add. Same thing. So let's change signs and add. These add to be 0. Perfect. These add to be 14x. And then what do we do next? Bring down, wait a minute. Yeah, okay. Bring down the 26. Okay? Then what do we do? Divide. X will go into 14x. How many times? Say again? 14 times. Plus 14. And then you do what? Multiply. 14 times x is 14x. And 14 times 2 is 28. Okay? And then I like to change signs and add. So I'll change that to a minus and change this to a minus. Okay, and then I'm going to add, and what does that give me? That goes to 0, perfect, and this does what? Negative 2. So you have a remainder of negative 2, or you could write that as minus 2 over x plus 2. There is your answer. Does everybody see that? Do it just like you do long division, and I can tell some of you long division is a little bit rusty, okay? But this is how to do it. Have we run out of time? Oh, how sad. Now, the bad news of that is there's no test on Monday because we didn't quite finish 10.5B. So that means Monday we'll finish this Module 10. We'll go over any questions you have on Module 10, and then we'll go on and start on Module 11. That means the test will be Wednesday on Module 10. Is that okay? Be ready? That means you've got to have your quizzes in before you can take your test. So if you get your quizzes in, many of you turn them in today, and many of you turn in your research papers, which is really good. Get those in too, but get the quizzes in if you can by Monday. That way I can get them graded and back to you on Wednesday. Otherwise, you have to turn them in Wednesday before you take the test. Good deal. Y'all give me lots of grading to do. Thank you very much. Okay. Good deal. Thank you. All right. Oh, you're going. Yes, sir.
The quiz ain't online, is it?
It's what?
The quiz, is that the quiz?
Yeah.
Is it online?
No. You need a copy?
Yes, sir.
Okay.
I can turn it
Anyone who didn't get a copy of the quiz, please get it because you got to turn it in. You don't have to turn it in today.
Yeah.
Whoops, that's a test. Okay. Good. Thank you.
I'll be turning it Thursday?
Yeah, you can turn it in tomorrow. I'll be on campus all day tomorrow.
I'll have to be at the Birmingham.
What's that?
I have to be at the Birmingham tomorrow.
Okay, I won't be on Birmingham tomorrow. I'll be on Birmingham on Friday. Is that convenient for you?
I can just bring it to class Thursday. Or is that too late?
What's that?
Is Thursday too late?
No, you mean like tomorrow?
Or yeah.
Tomorrow is Thursday.
I'll find you tomorrow. Huh?
Okay. Either here, I'm here tomorrow and on Birmingham on Friday.
Thank you.
That's the last copy I have of that, so hopefully that's yes, ma'am. Okay. Just the book or the homework? Okay, just the book. Okay, let me get this in place. Oh, I mean, Mark. Oh, here we are. Where did we end up? Come on, where were we? You know, again, they did this one. We didn't do that one, so I need to go back. And I'm sorry, why do they do this? I don't know. We'll do this next time. Okay. Now, let me get this in place. Sorry. Otherwise, I won't ever know where I left off. Okay. Is that what you need? Or you need the ISBN on the back? What you need?
Back in first.
And front. Okay. There's the front. All right. Surely. Sorry it took longer than it should have. Good deal. Thank you. That order. Good deal.
Research paper, like, what type of math topic could it be?
Anything you want. That's the thing. You can write on a person. You can write on a theory. You can write on a application, use of it, whatever. You know, it's up to you.
Okay.
Yeah. Something to do with math. Okay. What's that?
Tesla, whatever.
I can't hear.
Tesla?
Tesla. Oh, great. Good topic.
Sorry, I had another question.
Sure.
I'm kind of confused on like when you assign the practice problems.
Yeah.
Do we come to you, or
Okay, they're
practice,
practice.
or do we determine it online?
Okay. No. Okay. Okay.
I'm sorry.
Good question. No, excellent question. Let's go to one. Okay. Here are the practice problems. Okay. They have their answers over here on page 5-6, which is bizarre, or S-6. There's the answer. So do them, see what you get, come over here and look at the answers. If you don't get the answers, then come see me and say, look, I don't see how they got that
So
answer.
whenever you say homework,
Yeah, that's homework. You do it at home.
That's for me to do it at home. They're not turning them.
You don't have to turn them in unless you're having problems with them.
Okay, all right. Just making sure.
Yeah, okay,
And I had another question.
sure.
The computer lab, right? The computer lab we have to go to the 0.
Oh, yeah, okay.
ABT. If we're not having trouble, we still have to.
You have to at least go
Okay.
and sign in and stuff, and then use it as time to work on your homework.
My professor don't even show up.
What's that?
My ADT professor don't even show up.
Your what?
The person that's over ADT for me doesn't show up because he got another class on Birmingham campus while he got a class here.
And who is that?
Brian. His name is Brian.
Oh, Dr. Bryant. Okay, have you let somebody know that? Have
They
they
ain't
done
changed
anything?
Because he wasn't here for the first 3 classes.
Yeah, well, if he has a class on the other campus, you see, somebody else did that. I didn't. They got their fingers in the pie, surely. And just go and work on it. Is there a student in there? Anybody to help you?
5 students in there.
Yeah, but anyone who's a tutor?
No.
Okay. Okay. And what time is that?
It's Fridays from 9 to 10:45, I want to say.
Okay, I don't think Dr. Bryant has a class then.
He does. Also, what I was about to say was, I'm not going to be here Wednesday, so can I take the test Monday?
Yeah, that'll be fine.
Because I got to go to the doctor that Wednesday and the following Wednesday.
Okay.
I'm just ready for the baby to come out of here.
In this.